Ever feel like your body's waging this war you never signed up for?
Yeah.
It's like this microscopic battlefield inside us, and we're just along for the ride.
Yeah, and it's a crazy complex world down there, you know?
Right.
Our source material compares our bodies to these complex machines under constant attack.
Okay.
And honestly, they're not wrong.
So true.
So today we're diving deep into the immune system, how it works, and how vaccines can help us fight back against all those pesky viruses.
Totally. We're going to break down this whole immune system thing and explore all those different vaccine types out there.
Exactly.
Clear explanations, memorable examples, pulling it all from this source material.
It's going to be a good one. So
Yeah, get ready to learn something new.
let's kick things off with Immunity 101, like the basics.
Okay.
Our source uses this analogy of a country defending its borders
I like that.
to explain these two parts of our immune system,
Okay.
innate and adaptive immunity.
Lay it on me.
All right, so picture this. The innate immune system is like your frontline soldiers, those white blood cells, always patrolling, gobbling up anything suspicious.
Okay. I like it. Always ready.
Fast, fierce.
Yeah.
But here's the thing.
What?
They're not the sharpest tools in the shed.
Oh.
Sometimes they attack the wrong things, even your own cells.
It's
Not the best strategy, right?
not ideal.
So that's where the adaptive immune system steps in.
Okay, the smarter guys.
Exactly. Think of it as the elite special forces.
Okay, so if innate is like the rowdy recruits,
Yeah.
who are these adaptive specialists?
T cells and B cells, the highly trained units,
Okay,
they learn, they adapt to specific threats,
much more efficient.
way more efficient.
What do they do?
Well, T cells are your assassins, eliminating threats directly.
Ooh.
And then you got the B cells, these are your strategists.
Nice.
They create antibodies to neutralize those threats.
That's amazing.
Right.
It's incredible how our bodies just have these intricate defense systems already built in.
Yeah, it's pretty wild.
What really blew my mind from this source, though, was how these cells actually remember the enemies they've encountered.
Oh, yeah.
It's like they have a built-in memory bank for every single germ you've ever fought off.
That's the beauty of the adaptive immunity.
Yeah.
It's why you don't usually get the same cold twice.
Oh, that makes sense.
Your body remembers and knows how to fight it off next time.
Wow.
It's pretty
And
cool.
The source even compares it to a blockchain, which
Oh, wow.
that sounds a little crazy to me, like our immune system is running on decentralized technology.
That is kind of wild, yeah.
Does that mean we could, like, upload human knowledge onto something similar?
Wow.
Like create some kind of collective brain for humanity?
That's where things get really interesting, you know. The potential is huge.
Right.
Imagine having access to this vast shared pool of knowledge, constantly updated and accessible to everyone.
That would be amazing.
The possibilities are mind-blowing.
Okay, so we've got this awesome defense system, but the source points out some enemies are just too tough.
Yeah.
That's where vaccines come in, right?
Exactly. It's like calling in the reinforcements.
Right.
Vaccines basically give your immune system a sneak peek at the enemy,
Oh,
a chance to practice before the real fight.
okay.
They introduce this weakened, inactive version of the virus.
Gotcha.
So your body can develop those defenses without actually getting sick.
So it's like a boot camp for our immune cells,
Exactly.
getting them ready for battle.
Yeah.
The source mentions side effects, though,
Uh-huh.
like sore arm, feeling
Oh,
tired.
yeah,
But that's just a sign that our immune system is working right.
absolutely. It's like a little muscle soreness after a good workout.
Right. No pain, no gain.
Exactly.
This is where it gets really interesting, though.
Okay.
There are all these different kinds of vaccines.
Yeah.
It's like a menu of immune system training options.
It is, and our source uses some great comparisons to help us understand them.
Okay.
So first up, we've got the inactivated vaccines.
Bye.
It's like studying a wanted poster of the virus. They use a dead version to show your immune system what to look for.
Got it.
But because it's dead, it might need a few booster shots.
Like a refresher course.
Exactly.
Cool. What are some examples of those?
Well, the flu shot, for example.
Okay.
Hepatitis A and B vaccines.
Mhm.
Even the rabies vaccine falls into this category.
I've definitely had a few of those.
Yeah, most of us have.
What about live attenuated vaccines?
Oh, those are a bit more intense.
How so?
It's like sending your immune system to a combat simulation.
Oh,
They use a weakened version of the live virus,
okay.
so it's a bit more of a challenge, but it can lead to a stronger, longer-lasting immune response.
Makes sense. But if it's a live virus,
Yeah.
even a weakened one, wouldn't that be riskier?
It's always about balancing the benefits and the risks.
Done.
They can be super effective, but they might not be suitable for everyone, especially people with compromised immune systems.
Got it.
You've got to weigh those factors.
Okay, so it's like wanted poster vaccines are the intro course.
Yeah,
Live attenuated vaccines are the advanced training.
I like that.
What are some examples of those live ones?
Think back to your childhood vaccines, like mumps,
Oh, yeah.
measles, rubella, chickenpox. Those are all examples of live attenuated vaccines that have been super successful.
That makes sense. But the source also talks about some newer vaccine technologies.
Oh, yeah, those are cool.
These sound way more complex.
They are?
Viral vector vaccines, protein subunit vaccines, and even mRNA vaccines. What's the deal with those?
So they're all based on that same principle of training your immune system,
Right.
but they use different methods to get there.
Okay.
Viral vector vaccines are like smuggling enemy intel using a harmless virus as a Trojan horse.
Okay.
Protein subunit vaccines focus on specific parts of the virus,
Gotcha.
like its weapons, to trigger a targeted response.
Okay.
And then there's the mRNA vaccine, which is like a whole different ballgame.
All right.
It's like giving your cells a blueprint for building a weapon against the virus.
Ooh, okay, so that one sounds like something out of a sci-fi movie.
It kind of is.
What makes mRNA vaccines so different?
Well, for one, there's no actual virus involved,
Right.
just a snippet of genetic code.
Wow.
This makes them potentially safer, faster to produce, which is a huge advantage.
Yeah, especially during a pandemic.
Exactly. And another cool thing is that the information about that mRNA sequence is often public.
Oh, wow.
Increases transparency, builds trust.
I love that.
It's like open sourcing the vaccine information.
That's amazing.
So anyone can see what's in it.
Transparency is key.
It is.
The source does mention some concerns, though, like the lack of long-term data
Yeah, that's fair.
and the storage challenges because they need to be kept super cold.
It's a new technology, so it's understandable that some people might be hesitant.
Right.
It's like jumping into a self-driving car for the first time, a little nerve-wracking.
Yeah, totally.
You don't know what to expect.
So how do these mRNA vaccines stack up in terms of safety?
That's a good question.
I know there are some concerns about them messing with our DNA.
That's a common misconception, but the source addresses it.
Okay.
It all comes down to this thing called the central dogma in biology.
Okay. I vaguely remember learning about that in high school, but refresh my memory.
It explains how genetic information flows in our cells.
Got it.
DNA is transcribed into RNA, which is then translated into proteins.
Okay.
Think of it like a recipe book.
I like that.
So how does this relate to the safety of mRNA vaccines?
Yeah.
Well, the central dogma shows us that mRNA can tell our cells to make proteins,
Good.
but it can't change our DNA.
Oh.
It's like using a recipe to bake a cake. You follow the instructions, but you're not changing the cookbook.
So even though mRNA vaccines introduce a piece of genetic code, they don't actually rewrite our DNA.
Exactly.
That's a relief.
It is, and the mRNA itself breaks down quickly in the body, leaving no lasting trace.
Like the recipe disappears after you've baked the cake.
Exactly. Just delicious kick left behind.
Okay, so we've learned about our body's incredible defense system.
Yes.
How vaccines are like these training programs for our immune cells.
Absolutely.
But what I'm curious about is
Yeah.
if vaccines work so well for our physical health, could we apply those same principles to other areas of our lives?
Ooh, interesting.
Like, could we create vaccines for bad habits
Whoa.
or negative thoughts?
I love that question.
Right.
That's a bit outside the scope of our source material,
Yeah.
but it really speaks to the broader implications of understanding how our bodies and minds learn and adapt.
Yeah.
If we can train our immune systems, what else could we train?
Imagine a world where you could get a vaccine for procrastination
Oh my gosh.
or a booster shot for self-doubt.
I need that.
That's a future I want to live in.
Sign me up.
But for now, we'll have to settle for these incredible advancements we've already made in immunology.
They are pretty incredible.
And hey, maybe someday we'll be able to download knowledge directly into our brains.
Who knows?
But until then, vaccines are a pretty good way to protect ourselves from those invisible enemies.
They are the best defense we have.
So that's all the time we have for today's deep dive into immunity and vaccines.
Oh, already.
I know, we've only just scratched the surface.
There's so much more to talk about.
But stay tuned for part 2, where we'll explore the history of vaccines and tackle some of those bigger questions surrounding this whole topic.
It's going to be good.
I'm excited for it.
Me too.
See you back here soon.
All right, sounds good. You know, it's amazing how we go about our day, not even thinking about the trillions of cells working tirelessly to keep us healthy.
Right, like this whole team of microscopic superheroes working 24/7 fighting off those nasty invaders.
I like that analogy.
But it hasn't always been this easy, you know? Our source actually takes us on a little history tour of vaccines,
Oh, cool.
starting with the OG superhero of immunology,
Who's that?
Edward Jenner.
Ah, Edward Jenner, the legend.
His discovery, the smallpox vaccine, back in 1796, was a total game changer.
It was.
The world's first successful vaccine led to the eradication of one of humanity's deadliest foes.
Talk about a legacy, right?
Right, it's incredible to think we completely wiped out a disease that caused so much suffering.
Yeah.
The source says it took 200 years and 6 generations to achieve that.
That's wild.
It really shows you the power of scientific persistence.
It does. The eradication of smallpox is like a shining example of what we can achieve through vaccination.
Totally.
It's a testament to the power of science and working together as a global community.
I love that.
Right.
So, if we could eradicate smallpox, does that mean we can do the same with other viruses?
Yeah.
Could we potentially eradicate,
Ooh, the big question.
the one that's been causing so much chaos lately?
I think everyone wants to know the answer to that.
Right.
Unfortunately, it's not that simple.
Why not?
Our source explains that smallpox had this crucial weakness. It
Right.
could only spread from human to human.
Oh, so no sneaky animal reservoirs or anything?
Exactly. Once enough people were vaccinated, the virus just hit a dead end, nowhere to hide.
It makes sense.
Yeah. But the virus we're dealing with now, it's a different beast.
Oh, no.
It can infect a whole range of animals, from bats and mink to even our household pets.
Wait, so even if we vaccinated every single human on the planet, this virus could still be lurking out there in the animal kingdom,
Yeah.
just waiting for a chance to jump back to us.
That's the scary part. It makes eradication a much tougher challenge.
It's like trying to get rid of mosquitoes when they can breed in every puddle of water.
That's a great analogy.
You might swat a few, but they just keep coming back.
Exactly. A never-ending battle.
Talk about frustrating. But even if we can't completely wipe it out, wouldn't widespread vaccination still help?
Oh, absolutely.
Reduce the severity of outbreaks, prevent people from getting really sick?
It can be a game changer, even if we can't achieve total eradication.
Oh, so?
Vaccination can help prevent infection in the first place, make symptoms milder if you do get sick, and significantly lower the risk of those serious complications that land people in the hospital.
So it's still worth it, even if eradication is, like, a long shot.
100% worth it.
Okay, the source paints a pretty grim picture of this virus's ability to spread, though.
Yeah.
They compared it to the flu in Japan, where cases dropped dramatically because everyone was masking up. But even with all those precautions, this new virus still infected a ton of people.
It's a tough one to beat.
It really is. It just shows how contagious this thing is,
Yeah, it can spread like wildfire.
even when we're doing our best to prevent it.
Exactly, which is why vaccination is so important.
So important.
Our best line of defense against those widespread outbreaks and the long-term consequences.
Speaking of long-term consequences, the source also talks about long COVID.
Oh, yeah, that's a big concern.
They say even after people recover from the initial infection, a significant percentage experience lingering symptoms like fatigue, breathing problems.
Yeah, it's scary stuff.
It sounds pretty scary. It's like this virus can have this long-lasting impact on people's health and well-being.
It's a reminder that we need to do everything we can to prevent infection in the first place, and vaccination is a crucial part of that.
Okay, so the message is clear. Vaccination is super important,
Definitely.
even if eradication is a long shot.
For sure.
Let's shift gears a bit, though, and talk about how these different vaccines actually work their magic on our immune systems.
Okay, let's get into the nitty-gritty.
We already touched on how they stimulate the immune response, but the source breaks down the specific mechanisms involved.
Cool.
For example, they explain how inactivated vaccines use dead viruses to train the immune system.
Yeah, like showing your immune system a mugshot of the virus and saying, hey, if you see this guy, take him down.
I love that. So it's like practicing with an enemy's corpse.
Exact.
Safe way to learn the enemy's features without risking actual harm.
Smart strategy.
But the source also points out that because the virus is dead in these types of vaccines, the immune response might not be as strong or long-lasting.
That's true.
That's why we need booster shots.
Right, to keep our defenses up.
Yeah. It's like the difference between reading about a skill in a textbook and actually practicing it in real life.
You got it. Hands-on experience always makes a bigger impact.
Totally. Practice makes perfect, even for our immune systems.
It does.
But what about live attenuated vaccines?
Oh, yeah. Those are the ones that use weakened versions of the actual virus.
Right, so it's like sparring with a weaker opponent in the training ring,
Exactly.
more challenging for the immune system, leads to a stronger, longer-lasting response.
Makes sense.
But wouldn't using a live virus, even a weakened one, be riskier?
It's a fair question.
Like, what if it accidentally mutates back into a stronger form?
Well, the weakening process is super thorough.
Okay.
It's like taking the teeth out of a lion. It might still roar, but it can't bite anymore.
That's a good way to put it.
These weakened viruses are carefully selected and tested to make sure they can't cause serious illness.
So it's like a controlled environment.
It is.
But it still seems like there's a trade-off between effectiveness and potential side effects with those live attenuated vaccines.
It's a balancing act for sure.
So how do we know which one's right for us?
The best choice depends on a bunch of factors, like the specific virus, individual health conditions, the overall risk-benefit analysis.
Makes sense. So it's not a one-size-fits-all situation.
It's not, and that's why it's so important to talk to your doctor.
They can help you figure out the best option for you.
Exactly. They're the experts.
So we've got the mugshot vaccines and the sparring partner vaccines.
I like those terms.
What about those newer technologies the source mentioned?
Oh, yeah, the viral vector protein subunit and the mRNA vaccines.
Those are some fancy names.
They are pretty high-tech.
What do they do?
Well, viral vector vaccines are like using a harmless virus as a Trojan horse to deliver a message to your immune system.
A sneaky tactic.
It is, and protein subunit vaccines are like focusing on the virus's weapons,
Okay.
teaching your immune system how to disarm them.
Smart.
And then you have the mRNA vaccines, which are like sending your cells a coded message that tells them how to build their own defenses.
That one still blows my mind. It's like something straight out of Star Trek.
It does feel futuristic, right?
Totally. The source even says it has the potential to revolutionize vaccine development.
I think they're right. mRNA vaccines are relatively easy to produce and can be adapted quickly to new viruses, which is a huge advantage in a rapidly evolving pandemic.
Makes sense, but I can understand why some people might be hesitant about this new technology.
I get it. It's new. It's different.
It's like fear of the unknown, right?
Really.
But the source emphasizes that mRNA vaccines have gone through rigorous safety testing,
Oh, yeah. Just like any other vaccine.
and that the information about the mRNA sequence is often publicly available.
That's huge for transparency and trust.
I agree. It allows independent experts to scrutinize the data too.
It's all about being open and honest.
And the source also addresses that common worry about mRNA vaccines altering our DNA.
Yeah, that one comes up a lot.
They explain that it's super unlikely based on this fundamental principle in biology called the central dogma.
Oh, right. The central dogma.
Can you break that down for us?
Sure. It basically explains how genetic information flows within our cells.
Okay,
DNA is transcribed into RNA, and RNA is translated into proteins.
got it.
It's a one-way street. RNA can tell our cells to make proteins, but it can't go back and change our DNA.
So even though mRNA vaccines introduce a snippet of genetic code, they're not actually rewriting our genetic blueprint.
Nope, they're just giving our cells instructions on how to build a specific protein, kind of like sending them a recipe.
And the recipe disappears after the protein is made.
Exactly. The mRNA breaks down quickly in the body, leaving no lasting trace.
It's good to know.
It's a safe and effective way to train our immune systems.
Okay, so we've covered a lot of ground here, from the history of vaccines to the different ways they work.
It's been a fascinating journey.
It really has. This deep dive into the world of immunology has been amazing.
It's amazing how complex and intricate our bodies are.
I know, and how far we've come in understanding them.
Vaccines are a true testament to human ingenuity and our ability to harness science for good.
Well said, but before we wrap up this part,
Yeah.
there's one more point the source makes that I found really interesting.
What's that?
They talk about the idea of individual choice when it comes to vaccination.
Oh, that's a big one.
What are your thoughts on that?
Well, it's a complex issue with a lot of different perspectives.
The source acknowledges that no vaccine is 100% safe, just like nothing in life is completely risk-free.
Right. We all make decisions every day based on our own individual risk assessments.
And it's about weighing the potential benefits against the potential risks, making an informed decision based on your individual circumstances.
It's not a one-size-fits-all situation.
And that's where talking to your healthcare provider is so important.
Absolutely. They can help you assess your individual risk factors and guide you towards the best decision for your health.
The source also highlights the trust we place in healthcare professionals.
It's a big responsibility.
They point out that the first people to receive any new vaccine are usually the healthcare workers themselves.
That's true. They're on the front lines. They see the impact of these diseases firsthand.
And if you're willing to get vaccinated, It really speaks volumes about the safety and effectiveness.
It does. It's a powerful argument for trusting the expertise of those who have dedicated their lives to protecting our health.
So while the decision to vaccinate is ultimately a personal one, it's crucial to make that decision based on sound scientific evidence.
And expert advice, not fear or misinformation.
We need to be critical thinkers, evaluate the information we're exposed to, and seek out reliable sources.
Couldn't agree more.
So folks, we've explored the history of vaccines, delved into the science behind how they work, and even touched upon the complex issue of individual choice.
We've covered a lot of ground.
But there's still so much more to uncover. In our final segment, we'll tackle some of the ethical considerations surrounding vaccines and explore the future of this ever-evolving field.
That's going to be a good one.
I can't wait. Stay tuned.
See you soon.
This source has been amazing. It's like
I know, right?
weaving together all these complex scientific concepts with like historical anecdotes, even a bit of philosophy.
It's really made us think.
It's given us a lot to think about, that's for sure.
And, even amidst a global pandemic,
Yeah.
we can still find those moments of humor, insightful comparisons, a sense of wonder.
It's not all doom and gloom.
Not at all.
So as we wrap up this deep dive into immunity and vaccines,
Yeah.
I think we've come away with a much clearer understanding of how our bodies fight back,
For sure.
the role vaccines play in that fight,
Huge role.
and the importance of, making informed decisions about our health.
Absolutely. Knowledge is power.
It really is.
The more we understand, the better choices we can make.
Our immune system is this remarkable machine,
It is.
so complex, adaptable, capable of learning and evolving to combat all these threats.
It's mind-blowing when you think about it.
And vaccines are like those specialized training programs,
Yeah.
helping our defenses prepare for battle.
Exactly. Getting those immune cells ready for action.
And just like any good training program, there are different approaches,
Right.
different levels of intensity, different outcomes,
It's about finding what works best for you.
based on your individual needs, risk tolerance.
You got it.
We've also seen how scientific innovation is constantly pushing the boundaries.
Oh, yeah.
From those traditional inactivated vaccines to this cutting-edge mRNA technology.
It's incredible how far we've come.
It really is a testament to human ingenuity.
And our relentless pursuit of better solutions.
It's exciting to be alive,
It is.
witnessing these incredible advancements in science and medicine.
Absolutely.
Who knows what the future holds? Maybe we'll even crack the code on that decentralized memory bank for human knowledge.
Oh, that would be amazing.
Right.
A world where knowledge is shared freely, accessible to everyone.
Constantly evolving and updating.
It would revolutionize how we learn and progress.
It's a beautiful thought.
It is.
But for now, we'll have to settle for the incredible advancements we've already made in immunology.
Which are still pretty amazing.
They are. And hey, maybe someday we'll be able to download knowledge directly into our brains.
Who knows, right?
But until then, vaccines are a pretty darn good way to protect ourselves from those invisible enemies.
Couldn't agree more. They're a testament to our understanding of the natural world and our ability to harness that knowledge for good.
Well said. So listeners,
Yeah.
we hope this deep dive has left you feeling empowered,
Informed.
maybe even a little bit in awe of this incredible complexity and resilience of the human body.
It's a marvel of nature.
It really is. And remember,
Yeah,
knowledge is power.
it is.
The more we understand about our bodies, the world around us, the better equipped we are to make informed decisions about our health and well-being.
Absolutely.
So keep exploring,
Keep questioning.
keep learning.
Never stop learning.
The Deep Dive signing off.
We'll see you next time.
Until next time.